All right, Fibonacci sequence, very famous sequence in the world of math. And the idea is that any term, any value in the sequence is just the previous two added together. So in this case, this 21 is really just 8 plus 13. And if you want to find the next one out here past 21, 13 plus 21, 34. Okay, so it's kind of actually perfect for recursive because you get a value by just adding the previous two. So just to make a little more sense of this, here's the Fibonacci numbers, starting with 0 and then 1, 1. This 2 is 1 plus 1, etc., etc. And so this is like the position or the input n. So that top thing up there, if that's not clear, the 0, 1, 2, 3, whatever, that's our sort of our value for n. And then we have the actual numeric value of the sequence down there. Okay, so the recursive case is actually hopefully pretty straightforward. So like if I want Fibonacci for the 8th position, for example, so in this case, sorry, I'm struggling to get this type in here. So if I want to do Fibonacci for the next spot, the 8th spot there, I would just need to do the previous two. So Fib position 7 plus Fib position 6. So I would take the 8 plus 13 to get the next spot 8. Right. Similarly, if I did Fib 7, I would just keep going backwards recursively. So Fib 6 plus Fib 5, the previous two values. Okay, and then if we just do this generically, so if our input is just n, then we just want to do the two previous, so that would be n minus 1 plus Fib, recall the method with n minus 2. So you just recall it, right, just like we did up here, recall it with 1 less than the input and then 2 less. The tricky part on this, honestly, is the recursive case. Or sorry, the base case. So the tricky part is like you could do like fib 0 equals 0. So I think certainly that would make sense to be part of the fib case, is if you have an input 0, you just return 0. The trick with that is fib 1 also needs to be a base case, because if I try and do fib 1 recursively, that would really do fib 0 plus fib of -1, right? So I'd be going back to a thing that doesn't make any sense, right? There's not a -1 position in this. So we need to make fib 1 a base case also. And so instead of doing it recursively, fib 1 is just going to be equal to the value we know it is, which is 1. So fib 1 right there. All right, so there's kind of two base cases, and you can, you could just say if it's a base case, return the value of n. So in here you'd return 0, and when n is 1, you return 1. Or I'm going to do it slightly different. So basically the idea is two base cases. So I'm going to do them separately. So if n equals 0, so I'm position 0, I want to return 0. And do if, so this is my second base case, n equal 1, then I just want to return 1. Okay, so you kind of have two base cases. And again, you could do if n equals 0 or equal 1, just return n, because 0 and 1 are actually just the n values at that time. So just a different way to do it. But finally, I forgot my else if. So I need to do else if here. And then else is my base case. So if it's not one of the base cases, I want to return the previous two. So I'm going to recall the method, which is called Fibonacci, and call it with 1 less than n, and then recall it a second time with 2 less than n. All right, and that should just run recursively backwards and backwards until we hit the base cases. All right, and we'll hit the go button and see. Looks okay. All right, well, hope that helps. Let me know if there's any questions. Just post them on that blog.